All right. In the previous video, I said the first step of doing U substitution is to choose a function and let it be U, right? And I said usually this is how we choose the U. Okay. So in this video, I want to use this example to show you that what will happen if we choose a U and that U doesn't work. Okay. So so here we are asked to solve for this integral. Now you can see this function is quite complicated, right? Compared with the function we saw before for the functions to which we can use a power rule, right? Now obviously this function we cannot use a power rule to find the antiderivative. Okay, so there are two persons, and each of them they choose a different U. Okay, so they follow this sentence. So one person thinks, okay, since it says we usually choose the quantity at the denominator as U, so he looks at this function and he says the denominator is x to the third plus 1 square. So he decides this to be U. And the second person, he follows this, the quantity raised to a power. And he saw that, okay, x to the third plus 1 raised to the power 2. So he decided to let this be U. Okay. Now let's continue and to see what happened to each person's result. So let's look at the first person. Okay, once we decided U to be this, the second thing is to figure out how to write du over dx. Now, during this process, we just take the derivative of this function. Okay, so here you might use you might need to use the techniques we learned early in the chapter of differentiation. So like power rule. So here is the power rule for finding derivatives, and product rule, quotient rule, a chain rule, right? Now for this function, we will use a chain rule to find the derivative. The out function is x squared. If you cannot see that, the out function is x squared, and the inner function is x to the third plus 1. So the derivative is 2x, and the derivative of the inner function is 3x squared. So that's why the derivative of this is 2 times gx, which is x to the third plus 1, times the derivative of an inner function. Okay, then the next thing we do is we want to solve this for dx, because we want to know which term should we use to substitute for dx. Okay, so if we solve this, we can find that dx equals du over this quantity. Okay, now let's stop here and take a look at the second person's result. According to the second person's choice, if u is x to the third plus 1, then du over dx, here we can find the derivative using power rule, which is 3x squared, and dx equals du over 3x squared, right? You divide by 3x squared, and here you multiply by dx, so you can solve for dx. Now, so here, since the denominator is replaced by u, and dx is replaced by this quantity. Therefore, we can rewrite the original integral into so x squared over u, and multiplied by the dx, which is a du over 2 times x to the third plus 1 times 3x squared. And because there is the 2x squares, they can be cancelled out. After we cancel this 2x squared, the integral is written as a du over u times 2 times x to the third plus 1. Or I can write as 1 over 2 times u times x to the third plus 1 and du. Now you see here, by doing this, the first person, he didn't make this integral to be easier. At this point, the integral involves the variable u and the variable x. It's not becomes easier. If you look at the previous example, after we did the u substitution, the function becomes much easier, right? Just 2u. Okay. So if you were the first person, if you were using this method, maybe at this point you wanna ask yourself, I may be choosing the wrong u. I mean, maybe the u should not be like this. Okay. Now let's take a look at the second person's work. Okay. So we said here let u be this, and dx be this. Now, x squared over u squared, because x to the third plus 1, this is replaced by u. Therefore, x to the third plus 1 squared is becomes u squared, and the dx becomes du over 3x squared. Now, after we cancel out this 2x squared, the integral becomes 1 over 3u squared du. And here we have only one variable, u, right? And we rewrite the function so to make it comfortable to see, to look. So the function becomes 1/3 times u to the power of -2. Now this function becomes easy. Why it easy? Because we can use the power rule to solve for this integral. Let me continue from here. If we factor out this constant, and next, according to the power rule, now -2 is n, is equal to n. So this is equal to u to the power of m plus 1, and this whole thing divided by m plus 1, and plus a constant. Because this indefinite integral gave us a family of the antiderivative, right? And so we simplify this. -2 plus 1, that's -1. We have a -1/3 times u to the power of -1, which is negative -1/3u plus a constant. And next, we bring the x back. We substitute x to the third plus 1 for u. So we got this result. Okay, we got this result. Now you can see here, if you choose a u which doesn't work, in the middle of solving the problem, you will see that the function or the integrals will become complicated. Right? So like here we have the function involves two variables. At that time, it tells you, okay, you should go back and think about another way to choose the u.